Hello everyone. I welcome you all to Kerala CBSE School online classes. In previous class we discussed first four problems of exercise 8.1. So today I will continue with sixth problem. I told you all to solve the fifth problem. So if you got any doubt you can contact me. So today I will continue with sixth problem. So here in sixth problem what they have given, they have given diagram for this one quadrilateral. Exercise 8.1, sixth problem. This is the parallelogram A, B, C, D. Diagonal AC of parallelogram ABCD bisect angle A. So here, what they are given? Diagonal AC. This is the diagonal AC of parallelogram ABCD. This is the parallelogram ABCD bisect angle A. So this is bisecting angle A. These two angles are equal. Show that first one, it bisect means this AC bisect angle C. This angle C also. Second one, ABCD is a rhombus. This ABCD is a rhombus. So now they are given this ABCD is a parallelogram, AC is the diagonal, and this AC bisects angle A means these two angles are equal. So that we have to prove bisect this AC bisect angle C also, and ABCD is a rhombus. To prove ABCD as rhombus, what we have to do? We all know that property of rhombus. What is that? Rhombus is also a parallelogram. Rhombus has all the properties of parallelogram. But what is the difference? In rhombus, all the sides are equal to each other. Therefore, if we prove here all the sides are equal, then it's called as rhombus. So first we have to prove this AC bisects angle C also. So now I will prove first one. ABCD is a parallelogram. You know that this ABCD is a parallelogram. So here in this parallelogram, I will consider these two angles here, angle BAC, this is the angle, means BAC means this angle, is equals to, angle DAC is equals to angle BCA, this angle. Why? Because these two are alternate interior angles. While these two are alternate interior angles, we know that this is the parallelogram, therefore opposite sides are parallel to each other, therefore AB is parallel to CD and this is the intersecting line AC. Therefore, these two are alternate interior angles, therefore these two are equal to each other. Again like this only, these two angles are equal. I will consider this as 1. And now these two angles are equal, therefore what I have to write? Angle BAC means angle BAC is equals to angle DCA. DCA, this angle. angle BCA. So these two are also alternate interior angles. I will consider this as second. Because again these two are parallel lines and this is the transversal line or intersecting line. Therefore, these two are also alternate interior angles. And we know that what are given? This AC bisect angle A. This AC bisect angle A means these two angles are equal. Therefore, what I will write here? Angle DCA, sorry, angle DAC. This angle DAC is equals to angle BAC. This angle. These two angles are equal because this is bisecting angle A. Therefore, these two angles are equal. First, I have written here angle DAC. This angle. Now, angle BAC. This angle. Angle BAC. So now I will consider this as third. So now what we can write here? First angle DAC is equal to BCA, and here BAC is equal to DCA by alternate interior angles, and these two angles are equal because AC bisect angle A. Therefore, these two angles are equal here. But here from 1, 2 and 3 what we can write? From 1, 2 and 3. What we can write here? Here, this DAC is equals to BAC. BAC is equal to BCA and BAC is equal to DCA. But from third, what we got to know? This DAC is equal to BAC. So if these two are equal, then these all four angles are equal. Therefore, from 1 to 3, what we got? These two angles are equal. If these two angles are equal, then all these four angles are equal. Therefore, what we can write here? Angle DAC equals to angle BCA. Angle BCA equals to angle BAC. Angle BAC equals to angle DCA. Angle DCA. So now, what we can write here? We have to prove these two angles are equal because we have to prove AC bisects angle C. Also means these two angles are equal. We have to prove. So here angle DCA is equal to angle BCA. We have to prove. So by this we can write directly angle BCA. Therefore, angle BCA is equal to angle BCA. Means these two BCA and DCA, these two angles are equal. Therefore, here you should write what you should write here. This AC bisect angle C also. Hence, first one is proved. AC bisects angle CL. Next, second one. Here below this you should write here AC bisect angle C. First one is proved. Now, from 4, what we got here? This I will consider as 4. Sorry, I will consider this as 4. So here, from 4, what we can write? These two side angles are equal. Angle BAC is equal to angle DCA from 4. See here in diagram. Angle BAC, this angle BAC, this angle equals to angle DCA. DCA means this angle. These two angles are equal from 4. So now we know that opposite sides of equal angles are also equal. Opposite sides of equal angles are also equal. Therefore, what are the opposite sides? Angle DAC. Opposite side of this angle is DC. DC equals to DCA. DCA means this angle. Opposite side of this angle is AD or DA. DA. These two sides are equal now because we know that these are opposite sides of equal angles. Opposite sides of equal angles. So now we got to know that DC is equal to this DC is equal to DA, and they are given that ABCD is a parallelogram. If ABCD is parallelogram, then we know that opposite sides are equal. This AB is equal to CD and DA is equal to CB. So here I will consider this as 5, and here DC is equal to AB. DC is equal to AB and DA is equal to CB. DA is equal to CB because they are given this as ABCD is a parallelogram in question only. Therefore, we know that opposite sides of parallelogram are equal. Opposite sides of parallelogram are equal. So now I will consider this as 6. So now from 5 and 6 what we can write? From 5 and 6, from these two, what we can write? This DC is equal to DA, and here this DC is equals to AB also, and this DA is equals to CB also. Therefore, here all the four sides are equal. Here this DC is equal to DA, and here DC is equal to AB, and this DA is equal to CB. Therefore, from 5 and 6, what we can write here? From 5 and 6, here I have written from 5 and 6, what we can write? All these sides are equal. Therefore, AB is equal to DC is equal to CB is equals to DA. So now all the sides are equal in parallelogram, and we know that property of rhombus. What is that? Here all the sides are equal. This has all the properties of parallelogram. Therefore, this is also a parallelogram, but here all the sides are equal. Therefore, hence here we prove that all the sides are equal. Therefore, this is also a rhombus. So here, what we did here? They are given that this is a parallelogram and this AC is bisecting angle A. Therefore, we have to prove this AC is bisecting angle C also, and this ABCD is a rhombus. So now, to prove this, first what we did here, these two angles are equal and these two angles are equal because of alternate interior angles, and these two angles are equal because of this AC is bisecting angle A. Therefore, these two angles are equal. Here we got first, second and third equations. From these three, what we got here, these two angles are equal. BCA is equal to DCA. These two angles are equal. If these two angles are equal, then we prove that this AC bisects angle C. Here below this you should write AC bisect angle C. And for second, here we have taken that this BAC is equal to DCA. This DAC is equal to DCA, means these two angles are equal from 4. Why we consider these two angles? If these two angles are equal, then we will consider opposite sides of these two angles, means this side CD and this side AD. We will consider these two sides which are not opposite sides of the parallelogram. If these two angles are equal, here we considered, then we will consider opposite sides, means these two sides are equal. These two are not opposite sides of parallelogram. So here, if these two sides are equal, then they have given this is a parallelogram, then opposite sides are equal, then these two sides are equal and these two sides are equal. So here from 5 and 6 what we got? Here all these sides are equal to each other. Therefore this is rhombus. Now I will move to the next problem. Seventh one. So for seventh problem, you can refer this rectangle, sorry, parallelogram. Here in seventh question, what they are given? ABCD is a rhombus. This is a rhombus. Show that diagonal AC, this AC bisects angle A as well as angle C. This AC bisects angle A as well as angle C, and diagonal BD bisects angle B as well as angle D. So now to prove that here angle diagonal AC bisects angle A as well as angle C, and this BD bisects angle B as well as angle D. First I will consider triangle ABC. Here in this triangle ABC, I will name this angle as 1, 2, 3, 4. This is angle 1, this is angle 2, and this is angle 3, this is angle 4. So now what we have to prove? 1 is equal to 4, 2 is equal to 3. So now first I can directly write this angle 1 is equal to angle 3. Why? Angle 1 is equal to angle 3 because alternate interior angles, because AB is parallel to CD and this is the intersecting line, therefore angle 1 is equal to angle 3. Alternate interior angles. I will consider this as 1, like that only. 1 is equal to 3 and 2 is equal to 4. Here angle 2 is equal to angle 4 and this is alternate interior angle. I will consider this as 2. Here 1 is equal to 3 and this 2 is equal to 4. Now I will consider triangle ABC. In triangle ABC, this is the triangle. In triangle ABC, this AB is equal to BC because this AB is equal to BC. Why? In rhombus, all the sides are equal. In rhombus, all the sides are equal. So now AB is equal to BC, and we know that opposite angles of the equal sides are equal. Opposite angles of equal sides are equal. Therefore, these two are equal sides now. Then opposite sides are also equal. Opposite angle of side AB is opposite angle is angle 2 equals to BC. Opposite angle of BC is opposite angle of BC is angle 1 because opposite angles of equal sides. These two are opposite angles of these two equal sides. This I will consider as 3. So now from 1, 2 and 3, what we can write here? Angle 1 is equal to angle 3 and angle 2 is equal to angle 4 here we got. But here we got angle 2 is equal to angle 1. This angle 1 is equal to 3, angle 2 is equal to 4. Here angle 2 is equal to angle 1 we got. Angle 2 is equal to angle 1. So now what we can write from 1, 2 and 3? What we can write? These two angles are equal. Angle 1 is equal to angle 4. Why? This angle 1 is equals to the angle 2 also. Therefore, angle 2 is equal to angle 4. Means this angle 1 is equals to angle 4. Listen here carefully. We have to prove these two angles are equal. Angle 1 is equal to 4. Angle 2 is equal to angle 3. Why? This we have to prove this AC is bisecting these two angles. So now we have to prove angle 1 is equal to 4, 2 is equal to 3. So but here by alternate interior angles 1 is equal to 3, 2 is equal to 4 we got, and here angle 2 is equal to angle 1 by opposite angles of equal sides. So here 2 is equal to 1 means here 2 is equal to 1 and this 2 is also equals to 4. Therefore we can write angle 1 is equal to angle 4. Like that only what we can write? Angle 3 is equal to angle 2 because this angle 1 is equal to angle 2 and this angle 1 is also equals to angle 3. Therefore we can write angle 2 is equal to angle 3. This angle 2 is equal to angle 3. Therefore we prove that what we prove? This AC bisects angle A as well as angle C. Hence we prove AC bisects angle A as well as angle C. Here you should write. After this, similarly we can prove this BD. You can write directly without any proof. You can directly write this BD bisects angle B as well as angle D. After this, first you should write AC bisects angle A as well as angle C. Below that, similarly, this BD bisects angle B as well as angle D. Or we can again prove by considering the angles 7, 8, 9, 10. Again, alternate interior angles are equal here also. We can try this. Alternate interior angles equal, and again you can consider any two sides and we'll get two angles are equal here because of opposite angles of equal sides. Then you can write again BD bisects angle B as well as angle D. But here we proved this AC, hence AC bisect angle A and angle C. Here I will write directly. Similarly, this BD bisect angle B and angle D. So what we did here? By alternate interior angles, these two angles are equal, and in third what we got? This 1 is equal to 2, and from these three you can prove angle 1 is equal to 4, angle 2 is equal to 3. I hope you all are clear with this 6th and 7th problem. In next class I will continue with 8th problem. Thank you all.